The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. Welcome. We've got an exciting Phius, that is Passive House Institute US webinar for you today. Get ready to learn all about the upcoming Phius Plus 2018 that will be released shortly. Welcome, and we have the Phius Senior Scientist Graham Wright on the line, and I also have Lisa White, the Phius Certification Manager. If you have questions while we're going through all the exciting news that Graham's going to be sharing, please use the chat or question box to type them in as we go along. We're going to hit those at the end of this event. And that's all from me. I'm going to hand it off to Graham.
Thanks, Katrina, and hello, everyone. So this is all about the 2018 update to our Phius Plus standard. And as you see there on the title slide, if I had to sum it up in a very short answer, what this is about is adding more nuance for different building types and supporting our overall transition to renewable energy. So the 2015 standard, that was mostly about adding nuance around sensitivity to climate factors in the certification criteria. And that was pretty successful, I would say. We've got the chart up there of the actual certified and pre-certified project numbers, so there's no projections in there. And yeah, it went way up in 2016 and up again in 2017. And I can't resist just a little bit of a plug for certification per se. You know, why would you certify? You know, costs extra and this kind of stuff. My main answer to that is that it shares the knowledge, both of how to do this, and it provides evidence to officialdom that like anything is happening at all in terms of, you know, really high performance buildings here. So I think it's still the case that we learn something new on about every other project, and so as we learn, we can teach the next people that come through for certification, and you know, the more documentation we collect, the more publications we can put out, you know, books of details and mechanical systems and this kind of thing. So on to Phius Plus 2018, and so there's two main parts to this. I want to talk about the changes to the certification criteria, and there are three aspects to that. There's changes to the heating and cooling, changes to the source energy criterion aimed at getting to zero, and some changes to the quality assurance. Excuse me. And there's also a couple of calculation method changes that we're making, significant changes to the calculation methods that I want to touch on. But before I get to the changes, let's review what stays the same. So this is, we're still wanting this to be a passive building standard, which means that it structurally prioritizes the use of passive measures in building construction. And the way we do that is we have limits. We put limits on the modeled heating and cooling loads in both the peak design load and the annual demand sense. And the connection there is that that's kind of what passive measures do. That's what they're good for, is reducing the heating and cooling. And so it's still a performance-based building energy performance standard, but in some aspects, you know, prescriptive requirements are the right tool for the job. So we still have all of that from the Energy Star program and the DOE Zero Energy Ready Home program, and it's still a pass-fail standard. So just to review a little bit, so back again on the review, or still on the review here, of where Phius plus 2015 was coming from. And so the approach we took to setting the heating and cooling was that we wanted to base that on economic feasibility. So there's the question when you're investing in passive measures like air sealing and windows and insulation, you know, how good is good enough? When do you stop and start looking at other kinds of energy saving measures, you know, mechanical equipment or renewables? And so to determine the appropriate performance levels that were economically feasible, we went to economic analysis, and that's a life cycle cost, you know, type of analysis. But you know, we imposed some constraints on that optimization. In particular, you know, we put in our study buildings that they had, you know, really good windows to make sure that we weren't compromising comfort, for one thing. And so those targets, those heating and cooling targets, are then sensitive to climate factors. But we're not just concerned with heating and cooling, we're also concerned with energy overall and the overall impact our buildings are having through their energy use. And so there's also a limit on modeled total energy use referred to the source, to the primary energy sources. And that is based on a different principle. So because our energy system right now is heavily fossil fuel dominated, that is mostly, so there's a pretty close connection to emissions, CO2 emissions. And we are under, according to climate science, a cap, a global cap. We have a carbon budget, basically, a total amount that the world industrial system is allowed to emit. Otherwise, we risk too much climate chaos. So you can kind of do a fair share calculation on that. And the philosophy there is that we've got one atmosphere, and emissions anywhere impact everyone. So it's reasonable to just sort of divide that budget by the number of people and see what we've got to work with. And so for residential, we said it makes sense to put a per person budget for the current year. And for non-residential, we said, well, we're gonna just go by square foot for that. So that is not climate dependent. That's, whatever must be done kind of thing. But we did recognize that, okay, if you have renewables on your building site and you're using the energy that they produce right there and right then, that is definitely like taking a load off of the grid. It's taking a load off of society and the emissions coming from the grid. So we'll net that out. We'll give you an offset for that. On the quality assurance front, this goes back to 2012, really, when we and before. We've always done air tightness testing. We've always done ventilation commissioning, and in 2012 we added a lot of quality assurance prerequisites from the DOE programs, including Indoor Air Plus and Zero Energy Ready. So for 2018, on the heating and cooling front, having based our heating and cooling criteria on economic analysis and on a cost structure for energy saving upgrades, we essentially signed up to update that in case costs change. And some costs have. Window costs have come down, for example. So we need to update for that. But mainly, so this time around, mainly what we're putting our effort towards is making the criteria sensitive to different occupant densities in the building. That has quite an effect on the balance of the heating or cooling that's needed in the building. And there's also the other thing that affects that is the building size, kind of the envelope to floor area ratio. And so what we're looking at doing is having a categorical difference between small and large buildings, and within those categories, some continuous adjustment for occupant density and for the size of the building. And in the course of our life cycle optimizations, we're going to extend the analysis period. It was 30 years for Phius plus 2015, and we're going to extend that to 70 years. Which is a more realistic for a total building life. So on the source energy front, significant change of framework here, and so the issue with the 2015 rule is that it didn't really motivate or show a path towards really getting to zero emissions or 100% renewables. And so essentially what happens here is at some point the building has done kind of all it can with passive measures, with active conservation measures, or mechanical conservation measures, with on-site renewables, and at some point, you have to, the responsibility basically shifts to the energy provider to reduce their emissions. And so we're going to allow off-site renewables to count, and there are several kinds of these that will be recognized. So but the limit then will taper to zero. So we're allowing more things to count as offsets, but we want the net source energy to go to zero, and we're still discussing the time frame on that, how fast to go. Our initial calculation in 2015 of what we could allow for the current year kind of pictured a linear glide path down to zero in 2050, but there's some sympathy on the tech committee for, say, aligning with Architecture 2030, which is a little faster. And there are other programs like in California that may be going even faster than that. So that will be still a little bit of discussion on that. But for 2018, we've decided what to do for that first step. So on the quality assurance front, we have some work to do on defining commissioning for non-residential buildings. So there are a number of existing standards and guidelines on this, and we're reviewing those. And at a high level, the priority is on things that really pertain to our energy performance requirements. Trina, how's my sound? Can people hear me, do you think?
I can hear you well, and no comments have come in to the contrary.
Okay, great. All right. So let me talk timeline for just a second here. We are running a bit behind, and that's mostly my fault. But by the end of this month, like in a couple of weeks here, we're going to publish our pilot phase protocol and open it up for public comment. A couple of weeks later, the comment period will close. We will then take some time to assess the feedback, finalize the protocol for the pilot phase, and open the program for submissions. And so for Phius Plus 2018, only WFI passive models would be accepted, mainly because of these calculation method changes that we're looking to do. So the pilot phase runs for 6 months. That will end in September of 2018, and at that point we'll publish the final protocol, but we'll continue to certify. So there'll be a phase-in period where you could submit under either Phius Plus 2018 or Phius Plus 2015 programs. That phase-in period will last for another 6 months, and that gets so from like mid-March of next year, mid-March of 2019, all the way through 2021. Then we'll just be certifying projects to Phius Plus 2018. All right. So let's go through those. Let's go through those criteria changes. So as before, as in 2015, we're using BOPT from the National Renewable Energy Lab, building energy optimization software to do life cycle cost optimization. And what this does is it's based on the Energy Plus dynamic simulation engine, and it runs building energy simulations, trying different combinations of energy saving options that you give it to try. And what it's trying to do is it's trying to maximize the source energy savings, and it's trying to minimize the what they call the annualized cost of that. So that's the sum of your energy bills plus the finance cost of the energy saving upgrades. They want to minimize that cost. So yeah, if you have upgrades that are really cheap, you can save money over the project analysis period. But other upgrades may be more expensive, and even if you spread out the payments on them, you're paying like more every month than what the energy savings is. So those are less desirable. So here's kind of an example of what's going on. So we're still in the process of running the simulations to determine these targets. This one was running yesterday. It happens to be a small house in climate zone 4B. And so BOPT always makes these graphs to show you what it's doing. So on the vertical axis is those energy-related costs. That's the energy bills plus the cost of the upgrade spread out over the analysis period, or the finance period. And on the horizontal axis is the source energy savings, and it's always relative to a baseline. So BOPT uses the Building America benchmark. Sometimes they call it the B10 benchmark, which is basically the IECC 2009 code. They picked a fixed baseline rather than try and chase the baseline through time. And so way over on the left there's a little point in gray at about $3,600 a year. That's the benchmark at 0. zero savings. And so you can see that we take like a pretty big step right away, all the way over to 35% savings, and that's because of the mandatory minimums that we put in. But from there, so the points in gray that you see on the scatter plot there are correspond to like different options or different combinations of energy saving upgrades that BEOP tried, and what the results were in terms of these performance and the overall performance and cost. And the dark line at the bottom and the black points, that's what they call the optimal path. So that's the lowest cost. That's the lowest cost solution or configuration at any given level of source energy savings that you ask for. It's just the bottom edge of the cloud of things that it's trying. And so for each one of those points on the optimal path, in turn, you can look at the options that it picked, and that kind of gives you an idea of what's the low-hanging fruit. So you want to, relative to the benchmark, of course, you want to move down and to the right. You want to save both energy and money, and at some point you get to a minimized annualized cost. And you can still save more energy by doing more upgrades, but you're going to give back on some of the dollar savings. And let's see, let me look. What's on the next slide? Okay. So I think maybe I'll go ahead and switch to the next slide. Okay. As in 2015, we're going to set up study buildings and give the optimizer a combination of envelope and passive measures, HVAC equipment efficiencies, and solar hot water to try in its search for overall energy savings. And this kind of makes, so we're interested in the passive measures and the heating and cooling, but this procedure sort of makes those measures compete with other energy saving measures, and so we can see where get more of a complete picture of where conservation overall kind of runs out of gas or rolls into diminishing returns. But we have, as I mentioned before, it's a constrained optimization where there's a few things that we're just not going to mess around with. For one thing, we're gonna insist on the level of air sealing that we require in certification, which is pretty tight. Some of you might be familiar right now. Our criterion for low-rise buildings is 0.05 CFM50 per square foot. We're going to change that here to 0.06, and that is based on. So what happened there is when we first set the criteria, that was based on some studies that Achilles hygrothermal studies that Achilles Karagiosis did for us that established that a certain air tightness in terms of CFM 75 should be okay. But when we converted that to CFM 50, we used a wrong flow exponent or one that was maybe a bit implausible. And indeed, when we checked the actual air tightness test results from built projects, we found that the flow exponent was off. So we're correcting that, and as a result of that, the CFM 50 criterion loosens just a little bit. So air sealing. Also, so air sealing is required on the, applied to these study buildings that we're using to predicate the criteria. We're also insisting that the ducts are inside, which is, one of our zero energy ready home requirements anyways. And we're holding the window U values down. The particular rule we picked to do that is based on ensuring winter comfort, even if you happen to have large glazing areas. If your inside window surface temperature is within 4 degrees C of the air temperature, you should be fine on comfort. But this also tends to drive the buildings toward low peak loads, which we want because we just want them. That's our deal. That's what this is all about. It's one of the defining features of a passive building. Setting up the study buildings this way kind of ensures that happens. But we're gonna, with those constraints, we are gonna let the optimizer do its work, and that is, that is still useful information. The calculations that it does to pick the option packages, and so once it's got all of its results, we look at what it found, and we choose one of these option packages somewhere near this minimum cost point. Maybe not right at it. For 2015, what we did is we calculated the whole curve all the way out to maximum savings, and it tends to kind of, if you just have conservation measures in there, it really tends to go asymptotic at some point. You just keep piling on wall and ceiling insulation, and it doesn't do anything. And at some point the building's perfectly airtight, things like this. So what we were looking for in that case was sort of the knee of the curve, like where it rolled into diminishing returns. So we were being a little bit aggressive in pushing past the minimum cost point to get a little bit more savings. Maybe do something that would reduce peak load a little bit, even if it cost a little bit more. It wasn't quite cost minimal. But this time we might go ahead and pick the minimum cost point. As I say, the results, the calculations are still rolling in, so but we'll do something systematic and something near the minimum cost point or the rollover point. A slight difficulty or disconnect in that it's great that we're using the state-of-the-art calculation engine that's built into BOPT to do these detailed studies, but we don't certify with that software. We certify using WFI Passive. So having picked this study building and its upgrades configuration, then we have to remodel those in WFI Passive to see what the heating and cooling loads could come out to be under our calculation protocol. And there are some significant differences there in some cases. So we want to make sure that this is tuned to our certification protocol, so we have to do this crossover. Then we're going to do, once we have that data set, we do some curve fitting on it to set the rules for how the heating and cooling criteria work. What the sensitivity to the occupant density and the building size would be. So that is all pretty similar to our procedure from 2015, but some differences are that in the 2015 development, that was really focusing on climate factors. We looked at a lot, we had one study building, and we looked at a lot of different climates to come up with targets that were sensitive to several climate factors, not just, you know, average temperature, but you know, the peak design temperature and the design humidity ratio and the solar access, all this stuff. For 2015 or for 2018 here, for the pilot phase, we're really more interested in these sensitivities to building size and to occupant density. So we're going to focus our calculation resources on that to start with. So the climate sensitivity aspect of it will drop in the pilot phase to a zone by zone set of rules. But we're looking, you know, we're more interested in getting feedback on the adjustments for occupant density and building size. So we're looking to have you know, a more nuanced set of rules on that. Eventually, we want both, or for the final protocol, we would like to get back to something more like the continuous climate sensitivity that we had in 2015. This requires more computations, so we will work on that during the pilot phase and try to restore that in the final protocol in September. And as I mentioned, another difference is that we extended the project analysis period. So when BOP's, you know, doing its calculations, it's adding up the energy savings over whatever analysis period you set, and also the cost. So it's got a fairly sophisticated financial model in there. It accounts for the finite lifetime of components. You know, there's things that have to be replaced, like HRVs and windows. They don't last 70 years. Walls do. So it takes all that into account. It has inflation rates and discount rates and mortgage rates and energy cost escalation rates that you can put in. So we've picked what we believe are reasonable assumptions for all of that. And but we did last time the project analysis window and the financing window were both 30 years. This time we're keeping the financing at 30 years, but extending the building life. And that we did a preliminary experiment actually, where we looked at this, and it wasn't, like, compared to the occupancy effect and the building size effect, it didn't really make that much of a difference. So we thought, well, we might as well be more realistic about the life of the building. So when we come to actually write the criteria, as I mentioned, the current thinking is that we'll have two entirely separate, two categorical differences between a small building and a large building. I'm not confident that I can get a continuous rule that will fit across both. But within those categories, the idea is that the criteria would be sensitive to the envelope to the floor area ratio and the occupant density in a continuous way within a certain range. So we've got in our study this time around 5 different building sizes. There's 2 small ones. There's the typical house, the 26 by 40 foot 2-story that we had before, but we're doing a smaller version of that as well, a little bit smaller. It's more like it's like 1,000 square foot ICFA internal conditioned floor area type of size, which is about the lower end of what we see in certification and kind of a drop-off point in the housing statistics data too. There's not a whole lot that gets built smaller than that, at least in the U.S. And then for the larger buildings, we take a big step up to the DOE commercial prototype mid-rise, which is a 4-story, and then we do high-rise, and we do 6- and 10-story versions of that too, to get 3 levels of envelope to floor area ratio. Within each of those, we look at 3 different occupant densities, which correspond to about 235 to 875 square feet per person. And that again is about the total range that we see in certification, and it's corresponds to kind of the upper and lower quartiles in the housing census data for multifamily. So here's just a visual of what those buildings look like, and they're still not even to the same scale. So that little house is 25 feet wide, and the 6-story there is 50 feet wide. Okay, so that's the story on the heating and cooling. So moving on to the source energy criterion, I won't go through this in detail, but I think I'm doing my math correctly here on this kind of fair share calculation. Kind of the bottom line there was in 2015, we were working with this source energy limit of 120 kilowatt hours per meter squared, or 38 kBTUs per foot squared of source energy. We wanted to look at that through the lens of the global carbon budget and see whether that global carbon budget would allow any relaxation of that limit. Essentially, the answer we came up with is no. That's about right for the current year if you're looking to taper to zero by within 30 years or so. So we determined that current year, the year 2015 source energy budget for the building sector was plausibly about 4,200 kilowatt hours per person. And that assumes, buildings are going all electric, but it's supplied by mostly non-renewable generation. We found that we had to relieve that limit because we also wanted to be more realistic about the amount of energy that's used for residential lighting and plug loads, and that was an increase from what we were assuming before. So we had to basically relax the source energy limit, but we said even at the time that we wanted to ramp it back down to 4,200, and ultimately what in fact has to happen is that the use of all this non-renewable generation should taper off to zero. So because our current protocol only recognizes these on-site renewables for reducing the load on the grid, if we kept that same framework and tapered that limit to zero, it would basically force all buildings to be off-grid, unless the grid decarbonizes, just as fast as we would like it to. So as I mentioned before, the idea here is that at some point the building's done all it can with its conservation and the on-site renewables that it has access to, and it has to look to the energy provider to go renewable. So for 2018, we're doing a change of framework then on source energy. So that limit will taper to 0 by 2050 at the latest. We're still discussing how fast to taper it. I suppose there's also the question of how front-loaded or back-loaded that process should be. It doesn't have to be linear. But for 2018, for Phius 2018, we at least want to get back on track with that original sort of taper, linear to 2050 idea that we did before, and that number is 3840 kilowatt hours per person for residential. So that is like overall, I would say an increase in stringency. So the jury is still out on the stringency question for heating and cooling. The idea there is not, we're not biased in any particular way there. We're just kind of waiting to see how the calculations come out on the economic feasibility. But on the source energy front, yeah, we're looking to get movement here to motivate building planners and energy designers to look for more solutions. And so, yeah, we're looking to taper the limit down, but that limit is now on net source energy, annual net, and all of the renewables options listed there would be recognized as offsets. So all the on-site generation, not just the coincident use fraction that we credit now. Any directly owned off-site renewables, community renewable energy, power purchase agreements, and even the renewable energy certificates, if they're Greenie certified, and we're going to discount those by about 80%. So you have to buy really like 5 times as many of them. Right now, those are really cheap. I use them myself in my house, and they're only like 2 cents a kilowatt hour. So if we didn't put some curbs on them, people would kind of do nothing else but that and get basically a free pass. So let's see, and that so that list on the bottom half there of the slide is what's going on there is when we wrote our blog posts this year back in like August and November about the direction that we were thinking of going with the source energy here for Phius Post 2018. We heard from the ASHRAE 189.1 committee. That's the ASHRAE 189.1 is the green construction code. It's ASHRAE's green construction code. It's like the IGCC, and in fact, those two are being harmonized at the moment. And so, what we heard from that committee, and that standard, by the way, is for non-residential. It's for things that are not low-rise residential. But even so, they mentioned, we're aware of this exact issue, and we're working on it too. And this is what we're thinking, basically. So they're working on basically deciding what to do for their 2020 update. But they kind of gave us a heads up on the direction that they're going. And so what we're going to do here at Phius is pre-align with that. So these ideas are somewhat pre-aligned with the way that this ASHRAE Green Code Committee is going. So there are some additional provisos to note about that. So it's not just that it's possible or that there's some vague intent to purchase this off-site power. The building owner actually has to present a contract that they're going to do this, and for a significant amount of energy or time, a significant number of years worth of energy into the future. Moreover, for any on-site renewables that you own or off-site renewables, you're not allowed to sell RECs off of that. You have to retain them. If you sell the RECs, then you're basically double counted. Final note there is, they're aware of things like Solar City where it's on site but you don't own it. So in that case, you have to go out and buy equivalent RECs to compensate for that. All right. Moving on to the quality assurance and commissioning. Again, this is something we're running a bit behind on, but at least for the pilot phase, we can say this. We've got a short list. So the details right now are being determined basically on a project by project basis between Lisa, the quality assurance manager, and the rest of the certification staff. So that's Lisa and Chris McTaggart and maybe some input from the rest of us from time to time. And that list is focused on verifying the things that definitely impact our energy modeling. And the question, so we definitely want all of that. The question is what to say really about the other aspects of quality. There's a lot of stuff on the multifamily and single family checklists about that kind of thing, water management and so on. And the main question is what to say about those other aspects. So that's all the stuff to do with the criteria changes, the requirements. So moving on to a little bit of the shading algorithm or the calculation protocol changes. We have a new shading algorithm that Fraunhofer developed, Fraunhofer Institute of Building Physics, and what that's doing is it's an hourly preprocessor that's going to calculate monthly shading factors to plug into to the monthly method calculation that's used for the rest of the calculation in Multipassive. And what that does is it actually figures out the sun angles on an hour by hour basis. So all you have to do is actually draw the building geometry, the overhangs, and it figures all that out. So it's no longer necessary to put in reveal entries or overhang entries, although you will still be able to do that to use the more simplified methods. So we think this is an improvement in accuracy on the passive solar front. Also, we're going to make some changes to the hot water protocol. We've got a couple of issues here. Having adopted the EPA water sense requirement on the delivery time for hot water, one of the things we need to do is allow people to do some design calculations to see if they're likely to meet that field test. So that's part of it. And related to that, another pipe heat issue is that our current algorithm for calculating the heat losses from the water pipes doesn't scale very well to large multifamily buildings. So we're going to fix that. and we're going to align with ResNet on some other things like drain water heat recovery and how the energy for washers and dryers is accounted for. And so for a bit more, just a few final details on source energy use then. We want to include an energy in the source energy associated with all the water use, with pumping all the cold water to the building and the wastewater treatment, kind of a nominal number for that, because that's also an energy impact on society. And in terms of so we get questions fairly often about the multiplier from site to source for grid electricity, and we're sticking with national average on that per the Energy Star portfolio manager. You know, in my personal opinion, you know, again based on this common atmosphere idea, you know, any emissions anywhere affect everyone everywhere. And likewise, you know, the benefit of a renewable energy system that's deployed benefits everyone everywhere a little bit. So in my view, we should be using the world average source energy multiplier for everything. But I got talked into national averages, so at least we have national solidarity at that level. And the needle moved a little bit. We checked the portfolio manager, and the source factor for the U.S. dropped by 0.02. So yeah, on our way to decarbonization. So at this point, we can ready to see what the questions are.
Okay. We have a few, and I would like to remind folks that there is a question box in the GoToWebinar panel. So if you haven't found that yet, please, and have a question, please do go ahead and type those in, and I'll read them out so Graham can answer them. Graham, the first question: is this BOP analysis still based on a single-family 2,500 square foot home?
Yeah, I think I covered that. It's not. We're doing 5 different building sizes now.
Great. And the 0.08 for tall buildings, what is the definition of tall? Does it mean, how large does it mean?
I believe it's 5 stories and above, and also of non-combustible construction. Those are deemed to be lower risk.
All right. So as far as our timeline, the last opportunity to certify with 2015 is mid-March 2019. If the project is registered by February 2019 but without documents submitted, does it still qualify for Phius Plus 2015?
As long as contract and payment are in place, yes.
How many climate sites are there?
So for the pilot phase, we're doing 17 climate locations, and that's all of the representative cities that are listed, say, on the DOE commercial prototype building website or in NREL reports. So it's you know, Memphis, El Paso, Chicago, Albuquerque, San Francisco, Vancouver, BC, Baltimore, Miami, and so on.
Okay. Before I go on to the next question, I would like to let everyone know that this is worth 1 CPHC CEU. Graham, could you go to the last slide so that we can have that information up on the screen?
I could.
Great. So please note the URL down at the bottom. You will get a reminder email once we're done. that does include this information as well. But if you wanted to note it right now, please note the URL and the 5-digit code. And if anyone else still has questions, please go ahead and enter them in. I'm going to keep reading the ones we have already. How will occupancy for studio-heavy buildings be calculated?
I believe studios are assumed to be one occupant, so they're entered as like 0 bedroom. Is that right, Lisa?
Right. 0 bedrooms, so 1 person.
Everyone, that's the last question I have for now. If anyone else has any, please go ahead and type them in now. We have a few more minutes. Well, I'm not seeing any other questions, so Graham, do you have any last comments?
Nope, I'm good. Thanks everyone for listening. Please stay tuned, and please keep those certification submissions coming.
Yep. Lots more information to follow. Please be sure to subscribe to our newsletter. Information about subscribing can be found at the very bottom of the phius.org homepage. So please stay tuned and you'll hear more. Thank you everyone for attending today.